Hello students, my name is Shashank Shekhar. So let us continue with the chapter Some Basic Concepts of Chemistry. Till now we are dealing with numbers and all. How? We are seeing the number of moles, we are seeing the number of molecules. But see, doing the analysis of a given compound is very difficult in terms of these entities or counting the molecules and all. And we know a very good method to do so, to do the analysis is something called percentage composition. So what is this percentage composition? So basically, what are we doing here? We're calculating the percentage of the entity that is present in a given compound to do a much more easier analysis. Okay. So if you are given a new compound, suppose you find a new compound and you want to quantify it. So how you will quantify it? First of all, you will do the qualitative verification that which type of atoms are present there. Now to do the quantitative verification, you will try to find out what amount of that atom is present in that given compound. So first finding the type and then finding the concentration of each type. So there are two things. So to find the type, we have something called spectroscopic method. We use all those and find the constituent atom that are present in a given compound. But if you are asked now that how you will calculate the or how you will analyze their amount, then for that we have several ways, and one of those ways is percentage composition. So what we do in this percentage composition, suppose you found a molecule named H2O. So not H2O, you find a molecule that contains oxygen and hydrogen, right? Now further you found that the amount of H or the number of H atoms that are present is 2 and the number of oxygen atoms that are present is 1. Now, what is the percentage? Means what is the percentage of hydrogen atom and what is the percentage of oxygen atom, or what mass percentage is this hydrogen atom donating to the compound? So for that we have something called percentage composition. So if you have to calculate the mass percentage of a given element, then it would be the mass of that element in the compound divided by molar mass of the compound into 100. Clear? Now suppose we are calculating it for H2O. Then let us calculate it for each atom. So two types of atoms are present, hydrogen and oxygen. So first for hydrogen. So we know that two hydrogens are present. Okay. And each hydrogen has a mass of 1.008. So for mass of two hydrogens, we will multiply simply 1.008 with 2. That would give us the total mass that is present in 1 mole of H2O. Okay. So this is the mass. So let me do it on your board. So mass of oxygen and hydrogen. So for mass of hydrogen present in 1 mole of H2O. So in 1 mole, 2 moles of hydrogen are present. So here 2 is defining the number of moles. And 1 mole has a mass of 1.008. So 2 will have a mass of 1.008 into 2. That would give us 2.016 gram of hydrogen. Is this clear? Now percentage mass of, so if I talk about mass of oxygen, how it would be calculated? So 1 oxygen atom is present, 1 mole of oxygen atom is present in 1 mole of water. Okay, 1 mole of oxygen atom is present in 1 mole of water, right? And 1 mole has a mass of 16 gram. That would bring us to 16 gram. So we can say that in 1 mole of H2O, we have 2.016 gram of hydrogen and 16 grams of oxygen. Now with this idea, with this quantification, we can use it to calculate the percentage mass. How you will calculate? So simply multiply this 2 by 1.008. So we have done this and multiplied it by the molar mass. So how can you calculate the molar mass? So it is very simple. Just add both of this, 16 gram at 1.00208 16 gram, 2.016. That would bring you to 18.016. So 18.016 or 18.02. So it is the approximate value multiplied by 100. So the mass of, I would say the mass of percentage of hydrogen would be 11.18. So we are talking about percentage composition. In that we are talking about mass percentage. Therefore, we have calculated mass percentage of hydrogen. What is the mass percentage of oxygen? So mass of oxygen divided by mass of water or the compound, that is multiplied by 100, that is giving us a 88.79 mass of oxygen. So although hydrogen has more numbers, but due to its less mass, its percentage mass is less. Whereas oxygen has less number of moles, but it will contain more mass percentage, or it will acquire more mass percentage. Next, let us take the example of C2H5OH. How I will calculate it? C2H5OH. So in such compounds in which one atom is repeated twice, I would suggest you that you add all of this such that it can be written in this way. So 5 plus 1, 6 hydrogen. So I'm writing both of the hydrogen at one place, one hydrogen. Okay. So there are three types of atoms. So types of atom are three, that are carbon, hydrogen, and oxygen. Now let us calculate the mass percentage of each of these. So first of all, mass percent of carbon. Now let us first calculate mass. Okay, mass of moles, mass of carbon in 1 mole of C2H6O. That would give us, so two carbons are present and each carbon atom has a molar mass of 12. So 12 into 2, that is 24 grams. So in 1 mole of C2H6O, 24 grams of carbon is present. Now if I talk about the mass of hydrogen in 1 mole of C2H6O, that would bring us to 1 into 1.008. Okay, that is 6 hydrogen. So 6 into 1.008. So 6.048. Clear? Now, what is the mass of oxygen that is present? Mass of oxygen in 1 mole of C6H6O, that will be equals to, so only one oxygen is present, so 1 into 18, so 18 grams. Is this clear? How we have calculated? So it is 16, not 18. 16 1 ja 16. Now next, what we were calculating? We are calculating the mass percentage. So mass percent of carbon would be, so how much was calculated? It was 72. Divide by total mass. Total mass would be 72 plus 6 plus 16. Clear? Into 100. I'm not taking 6.0048. I'm just taking 6 here. I'm approximating this value to first decimal place. So 72 plus 6, that would bring us to 78 plus 16. So 78 plus 16 would bring us to 88 plus 16, 88 plus 16, 94 into 100. So this will be the percentage of carbon. Next, mass percentage of hydrogen. So 6 is the mass that is present and total is 94. That is multiplied by 100. So this is the mass percentage of hydrogen. And what about the mass percentage of oxygen? 16 by 94 into 100 again. Clear? So sorry, two carbon atoms are present, so that would 24, and 24 plus 6 30, and 30 plus 16, that is 46. Okay, that is 52.14. Next is for hydrogen, so 6.048, 46.068, that would give us 13.13%. Now mass percent of oxygen, that is 16 gram by 46.068, that would give us 34.73. So the highest mass percentage of carbon, then we have oxygen, and then we have hydrogen. Now let us move to what is empirical formula and what is molecular formula and what is the relation between these two. Okay, what is empirical formula, what is molecular formula, and what is the relation between these two. So let us understand this with the help of an illustration, because that would be more beneficial. Okay, so suppose we take sugar, or we take glucose, I would say, that has the formula of C12 C6H12O6. Now what is the number that is being used here? Different coefficient, it is 6, 12 and 6. If we take a common number, a common ratio between this, that would give us CH2O. So we have taken 6 as common, that 6 as common. So therefore 6 1 is 6, 6 2 is 12, and 6 1 is 6. That would bring us to this formula, that is CH2. Now this is called as empirical formula. See, very easy to understand. So what we have taken, we have just taken a common number such that the ratio is bring to its minimalistic value. Therefore, we can convert the molecular formula into empirical formula. Now, what is the number that is being multiplied? That is 6. Now, if I ask you what would be the relation between these two, that would be molecular formula is equals to n multiplied by empirical formula. Got it? So the empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas the molecular formula shows the exact number of different types of atoms present in a molecule. What do you mean by this exact number? So it means that if you take a molecule of, say, glucose, then it will contain 6 carbons, 12 hydrogens, and 6 oxygen. But if we try to take a relevance from empirical formula, then that will give you a wrong piece of information. So a glucose molecule cannot contain 1 carbon, 2 hydrogens, and 1 oxygen. It would be incomplete. So the molecular formula actually gives the actual number of atoms that is present in the given compound, whereas the empirical formula gives you a simplest whole number ratio. Now, if the mass percent of various elements present in a compound is known, its empirical formula can be determined, and molecular formula can be further obtained if the molar mass is known. So we can calculate the molecular formula using the piece of information that we have. The informations are the mass percent of various elements and the molecular mass. Okay, the molecular mass, if it is given. So if we are given these things, then we can calculate, or we can determine the empirical and molecular formula both. So let us see illustration for that. So the illustration says that we have 4.07% of hydrogen, and 24.27% of carbon, and 71.6% of chlorine is present in a given compound, and the molar mass of, say, the compound is given as 98.96 grams. Now what is the empirical formula and what is the molecular formula? We have to calculate both of them. How you will calculate? So first, what we will do is we will calculate the number of moles. Now this mass percentage means that in 100 grams of compound, we have 4.07 gram of hydrogen and 24.27 gram of carbon and 71.65 gram of chlorine. So this is the meaning of percentage composition. Or we can say that, what we can say is that if we take 1 gram of these, then this will be divided by 100. So in 1 gram of compound, we will have this much, and this much mass of hydrogen, carbon, and chlorine. Now this is the simplest whole number ratio already. If you take this mass and divide it by the molar mass, that would give you the number of moles. Okay, or instead you can say it will give you the empirical formula. Let us see how. So since we are having mass percentage, it is convenient to use 100 gram as a starting material. In the 100 gram of sample above, we have this much, and this much chlorine that is present. That is according to the formula. Now here what they have done is they have calculated it for 100 gram. We can do it for 1 gram also or 100 gram also. Clear? Now dividing each of this by their molar mass, that would give us the number of moles. Quite clear? Further, what we will do, so we have calculated the number of moles. Therefore, that is the simplest whole number ratio. That is H4 C2 Cl2. But we are calculating what? We are calculating the empirical formula. So we will bring it to simplest whole number ratio. Now, do not make the mistake of considering this as a molecular formula, right? Because this is any ratio. Okay, this is any ratio rather than the actual number of atoms. So do not consider this as the molecular formula nor the empirical formula. So if it is possible to take a small common factor again, you can do it again till we get the smallest whole number. That would be the empirical formula. And how we will calculate molecular formula, we will see it. So for that we get this much. Okay, so we can write using this as CH2Cl. CH2Cl. Now what we will do, we will calculate the molar mass using this CH2Cl. So 1 carbon, 12, 2 hydrogens, 2 into 1.008, 1 chlorine, that is 35.453. So if you add all of this, that you would give you the mass according to the empirical formula. Now we have already the mass of compound, the molar mass of compound. We will divide both of this. That would give us the number with which we have to divide the whole compound's empirical formula. So we got it as 2. So 98.96 by 49.48. That brings us to 2. So if we multiply each of these by 2, so we will have here 2. Here we have 4, and here also 2. So it is C2H4Cl2. Now you will say, sir, we already got this. But see, student, there is a chance that this say number of moles that we have seen earlier may be or may not be equal to this. This is just a case of luck that we got the same stoichiometry here, this moles here, but it is not true always. So with this I end my lecture. We have seen what is empirical formula and molecular formula, and also we have seen percentage composition. Thank you.